Hello everyone, my name is Armand Stricker from the Listen Lab in Paris, and today I'll be presenting work done with Patrick entitled Enhancing Task-Oriented Dialogues with Chitchat, a comparative study based on lexical diversity and divergence. So task-oriented dialogues are generally based on very specific domain ontologies and databases, and therefore these systems tend to narrowly focus on accomplishing a user's goal. So one example is a user asking, I'm looking for a flight to Hawaii, and a typical task-oriented system would respond in the following way: how many tickets would you like? So this type of response is fine for moving the task forward, but it's still quite dry and is not as contextual as it could be. And so we find that most responses produced by these systems tend to be limited in their diversity. So if we want to keep users engaged and coming back to the system, we need to find ways to achieve less predictable and more diverse responses. So one way of achieving this is by adding chitchat to task-oriented dialogue system responses. Making a task-oriented dialogue system more conversational has the potential of making dialogues more interesting and diverse, and therefore elevating user engagement. So if you look at the same user query as before, I'm looking for a flight to Hawaii, an enhanced response would be, Hawaii is a beautiful destination. How many tickets? So this added chit-chat snippet immediately makes the response more contextual and engaging. And so the overall system response will vary a lot more based on the destination requested, and that will contribute to creating more diverse and interesting interactions. So several strategies exist to enhancing task-oriented dialogues with chit-chat, and we look at three of these strategies. So the first one, Accentor by Sun et al., augments the schema-guided dialogues dataset with an open domain dialogue system. So it uses the system to create chit-chat snippets automatically that can be either appended or prepended to the original system responses. And then these snippets are filtered by humans. The second case we look at is KTOD by Chen et al. So this also augments the schema-guided dialogues, except this time the chit-chat is knowledge grounded. So it uses entities mentioned in the original system responses, so Alejandro Sanz, for example, to perform information retrieval on Wikipedia. This retrieved knowledge is then injected into the original response by human annotators to provide more detail about the specific entities. Lastly, FuseChat by Young et al. Annotates the multi-WAS dialogue dataset. And so human annotators here create full chit-chat exchanges that can either come before or after the full task-oriented conversations. So they act as a conversational preamble or a continuation of the original dialogues. Despite all of these augmentations being useful and interesting in their own way, it's not clear which strategy is the most effective in achieving diversity, so making task-oriented dialogues less boring and repetitive. This is what we propose to find out. To find out which approach yields the most diversity, we look at three entropy-based metrics. The first one is Shannon's text entropy. When considering a corpus as a distribution of n-grams, entropy will quantify the average uncertainty in that distribution, and so by extension, in that corpus. In our case, a corpus is going to be a collection of system utterances. So Shannon's text entropy is a good measure of diversity because compared to simply looking at the number of n-gram types in a text, for example, this measure also takes into account their likelihood of appearance. So higher entropy will imply greater uncertainty and therefore higher lexical diversity, which is something that we desire here. And on the other hand, lower entropy will suggest more predictability and therefore lower lexical diversity, which is what we don't want. Looking at the bar chart on the left, this plots the entropy scores for each collection of responses. The lighter colors represent the enhanced responses, and the darker colors represent the original responses. So we can see that for KTOD and FuseChat in blue and in green, the enhancements do yield more diversity, and this is consistent across n-gram lengths. However, these entropy scores are still lower than ones for blended skill talk, which is a typical chit-chat dataset. So we can see that for each n-gram length, the entropy score for blended skill talk is much higher. Interestingly, we find that the Accentor enhancement in purple adds little to no extra diversity. If we look at the uncertainty ratio here, so basically this ratio would be at the end of a sentence such as augmented responses are more uncertain by a factor of dot dot dots the uncertainty ratio. So in this case, this ratio is below 1, which means that responses are actually more predictable when enhanced. And we attribute this to the fact that the snippets are automatically generated versus human generated for the other data sets and might therefore be quite repetitive themselves. The next metric that we look at is conditional next word entropy. So conditional next word entropy quantifies the uncertainty of predicting the next token in a sequence, given the preceding n tokens. Again, higher conditional entropy suggests higher uncertainty and therefore higher lexical diversity, and vice versa. We note, however, that this intuitive relationship between lexical diversity and entropy scores may actually vary based on the number of previous known tokens that we consider. So looking at the bar chart on the left, which plots the conditional entropy, when looking at a context length of 1, we find similar trends as before. So the enhancements in KTOD and FuseChat add diversity and not so much for Accentor. Looking at the blended skill talk entropy scores, we see a drastic drop as we extend the context length. And this trend is something followed by the enhanced responses for FuseChat and KTOD. So we see that in the end, when considering a context length of 3, the enhanced responses, so predicting the next token in these enhanced responses becomes more certain. And so this would make sense because if we have more lexical diversity, knowing the first 3 tokens gives us a lot of information and should help us determine which token comes next a lot more easily. And then looking at Accentor, we see that there's basically no change as we extend the context length. And this is also seen in the uncertainty ratio with basically a flat uncertainty ratio as we extend the context length. So this allows us to determine that Accentor is not as effective an approach compared to the other 2. Lastly, we look at Jensen-Shannon's divergence. So this divergence is a symmetric version of the Kullback-Leibler divergence. It evaluates the overlap or the distance between 2 distributions. And so this measure is useful because it's going to allow us to see how much the language in the enhanced snippets departs from the original responses or from more typical chit-chat that we find in the blended skill talk dataset. It produces scores at both the corpus and the token levels. And so it's also going to allow us, therefore, to find out which are the top K most divergent tokens. So the tokens that contribute the most to the overall divergence score. And so this will give us insight on the semantic specificities of each type of response. So first we look at the added chit-chat versus the original task language. We see that these distributions are closest for Accentor and most divergent for KTOD. Then looking at the added chit-chat versus blended skill talk snippets or responses, we see that distributions are closest for FuseChat and most divergent for KTOD again. So this proximity right here is due to the fact that the snippets are in the form of full exchanges or are inserted into full chit-chat exchanges, which looks a lot like what we can find in blended skill talk for FuseChat. And then for KTOD, the snippets are very entity specific, and so these entities might not be in that corpus, and so it makes sense that would be the most divergent. So for token level divergence, I'm going to focus on Accentor, but you can find details for the other data sets in the paper. So we identify for different settings the top 20 keywords that exhibit the highest levels of divergence. And so the tokens that are basically going to be most specific to the chit-chat are going to be found in Table C, so when comparing to blended skill talk, and Table A when comparing to the original task language. So what we find is that the most divergent tokens are service oriented. So we find elements like welcome, which is part of your welcome, or thank, which is part of thank you, and same thing here. For this specific chart, we also find tokens related to the tasks in the data set. So things like airlines or flight and PM. Notably, we also find that some of these most divergent tokens convey a positive sentiment. So we find terms like great, good, or enjoy, and these are the same, are also found in here. So this shows that one of the specificities of the added chit chat here is the positive sentiment that it conveys. And we hypothesize that this may help with counterbalance the lack of diversity and still help with engagingness. The key takeaways of our study are that Fuse Chat is most effective in achieving diversity. So enabling a system to perform both task-oriented and chit-chat dialogue yields the most diverse and engaging responses. On the other hand, Accentor is the least effective enhancement in achieving diversity. And so this is interesting because it slightly contradicts human evaluations on engagingness from the Accentor paper. Given our study, this higher perceived engagingness can be attributed to the positive sentiment that's conveyed by the chit chat, so it's semantic quality, more than to an actual increase in diversity and predictability of the responses. Lastly, KTOD has the most specific chit chat and also adds some diversity. Furthermore, it provides an interesting direction for future enhancements. This is the idea that, so this would be the idea of providing additional grounding for task-oriented dialogues. So this could be external knowledge, or this could be user-focused grounding. So things like user preferences, user emotions, contextual details that are given by the user that can serve as cues to diversify the response. We believe that this can contribute to dialogues being more unique and personalized, and therefore foster more diverse and engaging interactions. Okay, so thanks for listening. You can scan the QR code if you want to take a look at the GitHub repo and reproduce the figures. And otherwise, I'll be happy to meet you and talk about dialogue systems with you in Type A. Thanks.